1. 3 is less than 3. Bolo Palak.
Nothing.
3 is less than 3.
सर आपण आतापर्यंत काय केलं मी ओजस बोलतोय त्याच्यात जॉईन झालं
तू यायची वाट बघत बसलो होतो आम्ही गप्पा मारत होतो आता जस्ट सुरू केलंय बघ ट्रू और फॉल्स दिस इज व्हॉट इज इम्पॉर्टंट
ओके सर
बिफोर दॅट वी हॅव नॉट डन एनिथिंग इम्पॉर्टंट लिहा ह्याच्या पुढे तुमचं म्हणणं काय आहे ट्रू और फॉल्स शो मी युअर आन्सर okay so after having lot of discussion in English we arrive at conclusion saying that or is in maths used in inclusive sense. Inclusive means out of two statements connected by the English word or, if any one of the statement is true, then the compound statement is true. If both of them are true, of course the compound statement is true, and that is what is tabulated like this, and it is called truth table. So if P is one statement, Q is another statement, and if they are connected by the connective or, if both of them are true, then compound statement is also true. If first is true or second is false, then still it is true. So TTTF is the truth table for or, and truth table for and. If P and Q is your compound statement, it is if both of them are simultaneously true, then only compound statement is true. If any one of them is false or both of them are false, then the compound statement is false. That is what is the important discussion, and this will be used. This is the first thing that we will learn in 12th standard topic called logic. Okay, so we are going to make use of this fact in mathematics, and essentially we will use this or word in inclusive sense. Okay, so let us look at examples. Now find all possible values of x. Question 1, find which satisfy x square is less than or equal to 25. X square is less than or equal to 20. Let us list and understand the 9 types of intervals that we have learned earlier. Intervals of real numbers a comma b, closed interval. What does this mean? This means mathematically a is less than or equal to x is less than or equal to b. Geometrically, if you have a real number line, you have a, you have b, and all the points including a and b, between a and b. So these three are exactly same statements. They are no different. This is first. Second, a comma b. A is less than x is less than or equal to b. Okay, you start doing your work also, because there are about 9 diagrams we are supposed to draw. Dash, 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 dark circle. This is A, this is B. Interval number 3, A comma B. This is exactly equivalent, same. Maybe I will use equivalent by 3 letters, 3 horizontal line. This is if and only if I am using by mistake. This is equivalent. This is equivalent. This is equivalent. A is less than equal to X is less than A dark, B hollow, and all the points in between. 4. Open interval A, open interval. A is less than, X is less than, equivalent, open interval A, open interval B, and all points between A and B. 5. Minus infinity to B, open interval. Minus infinity to B. आता कसं लिहायचं? चुकलं ना? X is, सांगा कसं लिहू? X is less than
less than B.
6. A plus infinity. A is less than X. 7. Minus infinity to B closed. X is less than equal to B. Everything with B. 9. 8. Closed interval A plus infinity. 9. Infinity minus infinity plus. Everything. So these are the 9 kinds of interval of real numbers on real number line. Their geometric interpretation is like this. Maybe you can copy in 2 minutes. Okay, next question is x square is greater than 25 and therefore the answer is hollow circle minus 5 plus 5 and all the points to the left of minus 5 and all the points to the right of plus 5 will satisfy this. Okay, now question number 3. Now let me put you in trouble. X minus 1, x minus 2, x minus 3 is greater than 0. Now you can show me, see, you can use union and intersection of the set. So 1 comma 2 or maybe 10 comma 20 open union, 21 comma 22 closed union, something like that you can do. Okay, if you wish to do like that, I'm not giving you any hint. So what is the solution set of this? We are working on real number line, and the important stations that we have as far as example number 3 is concerned. Example number 3 is concerned, there are three important stations, 1, 2 and 3. In the beginning, you should draw hollow circle only, because hollow circle can be converted into dark circle. But dark circle, you will not be able to convert into hollow circle in your notebook. I can always do that on my whiteboard. So that facility is not there with you. So you start with hollow circle. We call these as critical points. They are critical points. That means they are important points. 1, 2 and 3 are important points. And the method for solving this problem is scanning from left to right. Scanning. Left is towards minus infinity. Right is towards plus infinity. I am not saying that this point is minus infinity or plus infinity. It is towards. So if I start walking from minus infinity, minus infinity, minus infinity, and if I keep putting values of x in this equation, what will I get? Say for example, I put 0 because 0 is to the left of 1 and I am coming from minus infinity. Whatever will happen to 0 will happen to every point to the left of 1. So I put x is equal to 0. If I put x is equal to 0, I get minus 1 into minus 2 into minus 3, which is negative and cannot be greater than 0. Therefore, I will not find any point to the left of 1 which will satisfy this inequality. Okay? So that those points are not available. I reach 1. So now it is time to figure out whether 1 is going to be a solution of that or not. If I put x is equal to 1 everywhere, I will get this fellow 0, making everything 0, but it is strict inequality. 0 is not greater than 0. 0 is equal to 0. Therefore, still it is false. Therefore, x is equal to 1 is also not the solution. Now, if I put something little more than 1, say 1.1, if I put x is equal to 1.1, this bracket is positive, this bracket is negative, this bracket is negative, one bracket positive, two brackets negative makes it positive, the entire product will be positive, is definitely going to be greater than 0. Therefore, all points between 1 to 2 will give you this inequality true. Scanning from left to right, I am moving from minus infinity towards plus infinity, right? Now I reach 2, let me put 2. This makes it 1, 0, minus 1, 0 in the product makes everything 0, greater than 0, not acceptable, hollow remains hollow. Any point between 2 to 3, say 2.5. This is plus 1.5, this is plus 0.5, so product is plus. We need not do actual calculation, we just want the sign. Therefore, these two will produce positive product and this is going to be negative, hence again inequality is false. You reach 1, you reach 3, put x is equal to 3, positive, positive, 0. Oh, 0 is not greater than 0, hollow circle. If you put anything greater than 3 now, x is equal to 4, positive, positive, positive makes it positive, greater than 0, and hence all the point to the right of 3, scanning from left to right. So my third type of solution is ready with me. That is what is the solution set. If I want to write it in the first form, I will write as solution set is equal to open interval 1 comma 2 union open interval 3, comma, plus infinity. Towards infinity, plus infinity or minus infinity, you cannot write this. This is totally wrong. You are trying to control infinity. Impossible. That is completely wrong statement. You can keep it open or you can close it for finite real number, not towards infinity. So have you understood this? Okay, let me ask you a little simple question so that I want everybody's answer to be correct. Let me put it in some other color. X. Let me make it a little difficult. X plus 1 into 2x minus 1 is less than equal to 0. Find the solution set of this. Resume recording. Now, here I said these 1, 2, 3 are called critical points. But then, here it was easy to find critical points. The method of finding out critical points, this is 0. So, if we forget inequality and make it equal, which values of x will make LHS 0? That question you have to ask yourself and find out all possible values of x which make LHS 0. That they are going to be your critical points. In this case, if I try to make LHS 0, x is equal to minus 1 will make LHS 0 and x is equal to 1/2 will make LHS 0. So now my real number line will look like this, and important points on that will be minus 1 and minus half plus half. Okay, understand the discipline. I have kept these circles hollow right now. I will start walking from minus infinity. I did not have to go far. I can take again x is equal to minus 2. If I take x is equal to minus 2, I get this bracket negative. I get this bracket also negative. Negative into negative becomes positive, and we want it to be less than or equal to 0. Therefore, walking from minus infinity till minus 1, I will not find this inequality satisfied by any of the x values which are less than minus 1. Understood? Now I consider x is equal to minus 1. Makes this bracket 0, this bracket some minus 3 or something, but 0 into anything is 0. And now here my inclusive sense of R comes into the picture. Is LHS less than 0? No. Or is LHS equal to 0? Yes. Then compound statement is true. And therefore, at x is equal to minus, I get 0. Hence, I make it dark. I take any value between minus 1.5. Easy value is 0. 1 minus 1, product is negative, less than 0. Yes, it is not equal to 0, but it is less than 0. So, inclusive sense of R makes all points between minus 1 to half part of the solution set. I put x is equal to half. The moment I put x is equal to half here, this bracket becomes 0, LHS becomes 0, and that is part of the solution set. If I put any value greater than half, say 1, this is positive, and hence it is neither less than 0 nor equal to 0, hence it is not part of solution set. Therefore, solution set is close bracket minus 1 टू ब्रॅकेट बघा झेपतंय का झेपत असेल तर जरा अवघड घालतो now essentially if you want to really draw the curve then if you put negative values of x less than minus 1 then we said that this product is going to be positive therefore if we really draw the sketch of the curve the how will this function look like it will enter from here. It will cross x-axis at these points, go down, it will come from back from here and disappear to plus infinity. Okay, so this is our parabola, this is our quadratic equation and leading coefficient is positive, discriminant is greater than 0, therefore it has got two distinct roots, it is opening up, maybe steep type of parabola and therefore if I want all values of y less than or equal to 0, I must walk between minus 1 to half. If I walk before minus 1, I won't get anything. If I walk after half, I won't get this inequality satisfied. Okay. In this case, if I want to draw the curve, if I put x is equal to 0, negative, 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 so the graph will enter like this. From minus infinity, it will come here. When it crosses x-axis, that point is not part of the solution set. It goes like this, it comes like this, and it disappears like this. So you are interested in positive values of y. Positive values of y. Therefore, this is our solution set. This is called wavy curve method. Write down whatever you want. Wavy curve method. Hence, my fifth problem is example number 5. X plus 2, x plus 1, x minus 1, x minus 2 is greater than or equal to 0. Solve. Scanning from left. How many critical points? 4.
4.
Minus 2, minus 1, plus 1, plus 2. Now you can do it little quicker because is equality allowed? Yes. So all the 4 points will be hollow circles. Dark circles. Correct? Now to the left of minus 2, all brackets will be negative. And hence product will be positive. Therefore, solution set is minus 3 to minus 2 closed union between minus 2 to minus 2 to minus 1. If we put any value, this bracket will be negative, this is positive. बरोबर है ना? If we put any value between minus 2
Correct.
to minus 1,
Positive and उरलेले
negative, positive, positive, positive.
तर निगेटिव्ह x -1 निगेटिव्ह असणार आहे.
Minus 2, minus 1, 1, 2. Any value in between, suppose we put minus 1.5, this is positive, this is negative, this is negative, this is negative. Overall negative, not acceptable. Minus 1 if we put, 0, acceptable. Anything between minus 1 to 1, minus 1 to 1, 0 if we put, positive, positive, negative, negative, product positive. Therefore, everything in between is acceptable. So maybe you can do this much, dark circle, this much, dark circle, and then between 1 and 2, if we put something, 1.5, this is positive, this is positive, this is positive, this is not acceptable. 2, acceptable. Anything after 2, acceptable. So minus 1 2 plus 1 closed interval union closed interval 2 plus infinity open. It is that simple. Okay, if I want to draw the curve, it starts from minus infinity. The leading coefficient is positive, therefore it starts from plus infinity, enters, cuts here, goes here like this. This is wavy curve. This is how the function will behave. And you are supposed to tap all values of x, which will give you all values of y above x-axis. And therefore these are the values of x. Example number 6. Two x plus 3, 3x plus 2, 3x minus 2, 2x minus 3 is less than 0. Let me quickly draw the diagram. Critical points are minus 3 by 2, minus 2 by 3, 2 by 3, 3 by 2. Leading coefficient positive. So the graph is going to enter like this, will go like this, will go like this, will go like this. And I want less than equality. Therefore, solution set is open interval minus 3 by 2, comma minus 2 by 3, union open interval 3 by 2. Example number 7. X minus 1 bracket square into x plus 2 should be less than or equal to 0. You should not get worried about that square. Right? Why is this not starting? Now, you should not get worried about this square. You should continue with your business of squaring from left to right. Critical point is 1 2 times. Okay, fair enough. 1 once and 1 1 more time. And 2. Equality available, therefore maybe we can make it dark at this stage. Scanning from left to right, if we put x is equal to 0, minus 1 square is plus 1, minus 2 less than 0, true. So the curve enters like this. If x is equal to 1, of course it is going to be 0. Now if I put something between 1 to 2, 1.5, this is positive square, and 1.5 minus 2 is negative. So positive into negative will continue to remain negative. And this is repeat root. So the curve is going to be tangent at this point. It is going to be tangent to x-axis because x is equal to 1. At that point, the graph is going to be tangent. Then it will move like this. Okay. So you want less than values, therefore all these values are available, including 1. Therefore solution set is minus infinity to 2. Are you there? काही जणांना समजते, काही जणांना नाही. Now, last example. Example number 8. X minus 1 cube x minus 2 or 3 square x minus 5 should be strictly greater than 0. Now there is a cube, so I can actually ignore this x minus 1 bracket square. So I can take it as x minus 1, x minus 3 bracket square, x minus 5 greater than 0, because this is positive. X minus 1 bracket square, if I ignore it is positive. Not necessary that every time you can ignore, but in this case I can. Critical points are 1, 3, 5. If x is less than 1, this is positive. Both these brackets will be negative, hence graph will enter like this. It will cross and come below. I mean, if x is between 1 to 3, it is plus 2, suppose. This is positive, positive, negative. This is going to be tangent. Anything between 3 to 5 is 4, positive, positive, minus. So again it will be negative. All circles hollow because strict inequality. You want greater than, therefore minus infinity to plus 1, open interval, union, open interval, 5 to plus infinity. Okay, that was the last problem. I know 5 minutes, but I cannot take a little difficult problem now because it will need good explanation. As far as your homework